Joining today, we have our special guest, Matthew Karashik. Matthew is an electrical engineer at EYP Mission Critical Facilities. Matthew's experience includes engineering designs, drafting, standards review, and NFPA 70 compliance. He also has experience developing single line diagrams, electrical floor plans, grounding plans and diagrams, and electrical details. Matthew's experience includes energy efficiency and cost savings analysis of engineering technologies of for data centers and power utilities. Matthew has done numerous site evaluations and demand site management using energy modeling and monitoring software tools. His experience includes design using Revit and BIM 360. Matthew has a bachelor's degree in electronics and communications engineering from New York University. So Matthew, welcome to our podcast.
Thank you, David. And thank you for having me on the podcast.
Absolutely. So tell me a little bit about yourself.
So, outside of what you mentioned, I'm an alumnus of NYU. I have a very strong interest in renewable energy and as well as the UN 2030 goals for zero carbon. I'm a big skiing enthusiast too. Yeah, that's a little bit about myself. Very, very standard electrical engineer.
I don't know about very standard once we get into the conversation that we have. So what is the conversation that we're having today?
So today, at least in my mind, we're going to be talking about the revenue side of creating a zero net carbon data center. And when I say zero net carbon, I'm referring to not just a data center that doesn't emit any carbon energy, but also a data center that doesn't require carbon energy to be created and therefore has what's called a true zero carbon impact on the environment. The way that I'm approaching this on my end, because there's so many different ways to, is through the use of blockchain applied to sustainability.
Wow. Blockchain, it's a trending topic right now.
Yes, it is.
A lot of people are tweeting about the different cryptocurrencies that are part of blockchain. So why don't we start with the first question? How does blockchain for zero carbon benefit colo providers or enterprise users or utility and microgrid power suppliers?
So David, it actually benefits everyone that you mentioned. And maybe I'll take it one by one. So for a colo provider, the zero carbon aspect of what I was describing. So we're talking about a zero carbon blockchain environment. The zero carbon aspect brings huge reductions to the size of distribution equipment and storage over time. That's coming from more efficient, compact technologies. That's just the way of the world. The blockchain aspect is actually really interesting. It's going to allow data centers to be built with less rooms and less monitoring required. So for a colo provider, it has a lot of benefit to the footprint and the cost of creating a data center facility. So for enterprise users, zero carbon blockchain actually brings benefit on top of benefit. I could spend all day talking about it. But what I would highlight is that it creates new resource trading. So the idea of being able to trade sustainability resources, trade energy, sublet server power, and even further, it can be used for an enterprise user, so the tenant of a server, to restrict carbon emissions without involving a colo provider. And then lastly, and this is far in the future, we're probably going to see data centers that don't actually have data halls. So very large yards of almost prefabricated colos. Each colo tenant will have their own enclosure, and that's going to be beneficial for everyone.
That's remarkable. So what you're saying is that in this case, the zero carbon benefit would not necessarily come from the data center. Like right now, one of the discussions about sustainability, it's inside the data center. We're talking about, for instance, no generators, or sometimes considering different types of new technology, sustainable new technology, solar power. We're talking about all kinds of turbines. Is a wind. Now, in this case, we're talking about outside of the data center.
Yeah, and I mean, those aspects of renewability that you mentioned, they're great and they are important. But what we're not focusing on in the industry is what you said outside of the data center. So, how clean is the power that's coming in? How able are we to track and verify that it's clean? And how are we able to empower the energy that's coming into us, especially from a microgrid, a distributed energy, and from the perspective of the utility? Even you could, in this case, you could say that for the utility or even an independent renewable supplier, we want to be considering that these systems that I'm talking about, they help create cost savings potential through energy efficiency. They help reduce the odds of service outages, and they're going to create new revenue opportunities as these kind of decentralized data centers and microgrids collectively become a market threat to macrogrids. It's really amazing.
So how effective are blockchain and decentralized networks for tracking sustainability?
I don't think I could actually overstate how effective the tracking potential of this is and the decentralized networking. So like the low-end implementation is going to see massive improvements through these the supposed Internet of Things in the ability of all users, so that's enterprise, facility, distribution, transmission, and power generation, all users to verify just how zero carbon they collectively are while maintaining data privacy and anonymity when relevant. So even a small business, if they are in a data center or somehow related to a microgrid, the moment they enroll into this blockchain, they're able to know whether or not they're actually getting renewable energy. On higher end, so that's what we might call this multi-layered networking architecture at a higher order. It's almost like a blockchain on top of a blockchain. It's going to allow us to verify, exchange, and process data at the most atomic of levels. Every meter, every transformer, every power line is going to be acting in synchronicity, like a giant machine almost.
Remarkable. So what new revenue opportunities are you creating through your research? How can your idea for a decentralized network of power supply bring profit potential to a microgrid or a data center, especially in a green energy context?
So that actually was one of the major outcomes of the research that I've been doing. I realized that by decentralizing a network of power supply, we actually create, in a way, a new trading market. Let's imagine, just as an example, that we had a microgrid. It could be a bunch of utility buses. I mean, not utility buses. It could be a bunch of buses. It could be a bunch of colo data centers. The important thing is that they're getting energy from a bunch of different renewables. Each renewable that enrolls into this microgrid normally would be a competitor against each other. But because of blockchain, because we're decentralizing decision making, we actually give everyone involved in a blockchain the ability to trade energy with each other. So what we're going to see is that microgrids, data centers, they're going to be like virtual trading floors. So one server can sublet out its processing power to another server for some agreed upon rate. And we could propagate that through an entire data center environment.
Wow. What new ideas do you imagine will address the shelf life of current blockchains?
So something that I'm very interested in is this supposed, and it's a very recent development. I think a paper by Streambit might have come out talking about it. This proof of collaboration. And what proof of collaboration does is it takes proof of work, which is the kind of background for Bitcoin. It takes proof of stake, which is kind of what Bitcoin's competitors like Ethereum are kind of shifting towards. And it says we can actually figure out how many blocks can be created before Bitcoin's kind of done. We can do the same with Ethereum. And also, we have to have a lot of resources, a lot of power in order to actually run Bitcoin, to be a competitor. It takes those ideas that kind of cause us to go back to a central system, and it throws it out the window. It says that everyone involved in this blockchain of green energy, let's say, is able to receive a return based on how much they put in. Now, why that's important is that's going to enable infinitely many more players to get involved. It's not going to say that you can only make this many Bitcoins before the blockchain is done. And most importantly, I would argue that, and how would I put this? Most importantly, it's going to empower smaller data centers, smaller microgrids who don't have the resources and infinite server power to create a blockchain where they can perform energy trading or where they can become zero carbon. If that makes sense.
Yeah. So going to that, you're talking about small microgrids. How small? Can it be the tiniest provider? You see, it seems that this is like a share economy of grids, regardless of the size.
And that's kind of the end goal, I think. Okay. And that's kind of where I think zero carbon as a concept for power distribution is going to go.
And we're talking about you can dedicate the demand generation. So in a case of an emergency, you can have how do you call it? Save your spot of energy if some of the other utility feeding or type of power that it's coming from one source, it doesn't work. Can you have a reserve allocation of that power?
Yeah. So anyone who's going to be able to set up power storage is going to benefit from the idea of one, zero net carbon, but two, blockchaining their zero net carbon. And that's because the communications network, that blockchain, especially in a zero carbon environment where you have a lot of different players, the environment it creates allows anyone to say there's a grid outage. And this is kind of the founding idea behind what's called demand response in energy efficiency for utilities. So the smallest data center, the smallest microgrid is going to say, over time, we're just going to keep trickling in power to some storage reserve, maybe via a rotary UPS. And when we see that there's a power utility, we're going to say, we're going to sell this much in at an agreed upon rate with the utility. And it's probably going to be higher during a demand event. So, and the classic problem that utilities and people involved in demand response had so far is that the players who kept a really low rate and had a really high reserve of power always would get picked for injecting into the grid for demand response. Smaller players would just have to take like a rebate check for having smart tech. If we go blockchain, the big players and the small players are able to cooperate. And the small players are all already collaborating through the blockchain. So they have negotiation rights at the table. That means the mom and pop shop can say, we're going to inject power into the grid, but we're going to get paid. And we know we're going to get paid.
Okay. So you mentioned about the smaller players, but also large players play an essential part of this demand generation. So the way that I see it, and please feel free to provide your thoughts. These players are talking about, no generations in the future data centers. They're talking about compressed air, kinetic from an energy storage, liquid air, hydrogen, chemical. Now, that excess of capacity, because usually they build the data center not thinking on day one. They build the data center and it starts with 10%, 25% of capacity. What do they do with the extra capacity that they have? That eventually they're going to need that energy, but at this time they don't need it. Can they sell it also and use this as a two-way street?
So, I mean, that is the hope. And so there are a couple limitations, and it's really right now, I say the impetus is on the authorities having jurisdiction and the utilities to say, we're going to put a little more food on the table for individuals who want to help us. So if you go to like more progressive areas, New York, California, maybe Colorado, you have a system set up where someone who's at a low capacity, they can save up that energy. In fact, sometimes they can even sublet out their spare server power, but they can save up that energy and they can negotiate with the utility, like having a fair negotiation to inject that power. But in a lot of regions, the utilities don't have those systems set up. So as soon as utilities in more in slower areas get those systems set up, you're going to be able to say, okay, I've got this spare power. I have some way of storing it. This data center can operate at a higher capacity. It doesn't need to. You can save that up. You can divvy it out. You can use all these algorithms to inject that back to the grid for a profit, or even to improve the payback period on your data center to lower it.
Now, where do you see the future of power distribution? If we really shift to the centralized system and green microgrids?
So the future, I see it. I believe it's going to be a future and eventually there's going to be enough microgrids that they assimilate the macrogrid. Macrogrid gets decommissioned. And what I mean by macrogrid, I mean the power utility. If you have a bunch of microgrids running on blockchain, which means, and something I forgot to mention, the most important thing about blockchain for power is it removes the need to have a utility meter verifying the energy that's flowing.
That was my
all the different individuals in the blockchain are able to keep each other in check so that no one can lie about how much power they received from upstream or how much power they sent downstream. So the utility is no longer serving that role for the microgrid. It becomes more and more incentive for someone to make a microgrid. We make more and more microgrids until eventually some of them realize that if we just stop connecting to the utility and we connected to each other, we could get all the way upstate to Niagara Falls. We could get to those large players in power generation. We don't need the utility. And so then something crazy happens. Anyone near any microgrid can say, hey, I'm a small family, but my roof is covered in solar panels. I'm paying off more than I'm making more solar energy than I can use, and the utility's not giving me anything for it. Do you want it? And then that microgrid, that data center, gets free energy at a rate in which they're paying less than they would to the utility from all of these decentralized resources, and the consumer's paying a lower rate for power every month than they ever would with the utility.
So it becomes a shared economy.
It becomes a shared economy, a true shared economy amongst power distribution and end users.
And the data center might play a key role because it will help pay for itself.
It will pay for itself. For everything that we're describing, there's got to be processing power somewhere. That's what data centers do. That's what we do. We provide that higher end computing, and we also enable smaller players in individual markets or local markets to have server resources at an affordable price. So that aspect is going to be important because processing power, even in the shared economy, it's going to be beneficial, but even more so because data exchange between all these microgrids is going to become more beneficial to, let's say, colo users as microgrids connect. We decentralize these data centers so they're all talking, and they're all talking with end users. And then anyone, no matter what the size, is able to exchange data. So as the zero net carbon microgrid improves, expands, propagates, absorbs the utility, the same thing's going to happen with data centers. So that data service that we're getting from the massive campuses out in California and Maryland, it's going to provide less utility than these distributed resources collectively over time. Data centers are going to be key.
Let's talk about edge data centers. Edge data centers are going to be location, location, location. Is this going to be also an incredible supplier of energy, of power within the whole country when it comes to this grid, a national grid, let's call it?
Yes, a national grid. No pun intended. So I think the idea of edge data centers
or a national microgrid, I guess.
Well, we don't want to we don't want to eventually get back to one big microgrid, because that's just the utility all over again.
Right.
But jokes aside, I think that the idea of an edge data center is kind of what it's going to evolve alongside this. The better that these microgrids get, the better ability an edge data center is going to have to connect to not just a larger data center, but to other edge data centers.
Right.
So it's going to have the same effect. And I hope that as price goes down, efficiency goes up. What if a mom and pop shop decides we want to make a data center? We don't want to just sell sandwiches. We're going to set up an edge and we're going to lease it out to whoever. So I'm very interested in seeing how edge is going to evolve alongside these technologies.
So let's save that conversation for another time because we're running on time, but this is remarkable. Matt, coincidentally, I don't know if it was a pure coincidence, but your background kind of shows how everything's going to be in blocks connected in your wallpaper background.
Oh yeah. I think it's the spirit. I think it's the spirit of engineering, and especially the spirit of data centers. We're connecting.
Yes, that's true. All right, Matt. Matt, I truly appreciate your time. What a wonderful conversation. I hope very soon we have another one of this type of sessions. Thanks again.
You're very welcome, David. I'm happy to come on anytime.
All right.